This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will construct a mounting platform for the rectifier filter boards, then connect the rectifier filter board for the internal power supply. I've printed off the layout for the strip board. Make sure we have this lined up and tape it to the bottom panel of the enclosure. And center punch. It's necessary to get a good view perpendicular in two directions. Now I'm masking off an area on the bottom to prevent metal shards from getting into unwelcome areas. And I'm using a drill at a very low speed, about 1/3 the normal speed. And drill the pilot hole. And now drilling the standard hole. It's about the size of a body drill for number 6 screw, a little larger. I'm using this rounded milling bit as a deburring tool also at very low speed. I find it, if I use it at a low speed, I can control it easier, and it does a very good job. I'll flip the lower panel of the enclosure and deburr the outside. It works nicely if it's slow enough so that I can control it. Now I'm going to insert 4 long bolts, number 632. Some people call these things screws, and I'm not sure exactly what to call them. I'm putting a washer down, then a spring-loaded lock washer, and a nut, and we'll tighten up on a nut, and that'll be the anchor for this support bolt. Do that 4 times. And so I now have 4 support bolts for the rectifier filter boards. And I'm using an open-ended wrench to keep the nut in place while I tighten up using the outside screws. Now we're going to put the nuts that will be the supporting platform for the rectifier filter boards. And put a tooth block washer on top of those first nuts. And now put on a second nut. Now, when these tube nuts are positioned at the proper height, they're going to be tightened up against each other and provide a very stable platform. Those nuts are not going to move. So let me check to make sure they've got the clearance on the bottom. And now I can lock these nuts one against the other. And one final check. The board on the bottom is for the internal power supply, and the board on the top is for the external power supply. Putting some washers, spring-loaded lock washers, and then nuts on top. You want to make sure that not only is it adequate space clearance on the bottom, but also the 2 copper-clad sides are facing one another, and I need adequate clearance for that. Now for the secondaries. Piece of tape on the bottom, stripping some wires for the corresponding leads in the secondary. The first couple of wires are for the 5-volt internal supply, and the next 3 are for the -15 and +15 volt supplies. I'm going to apply some liquid flux and then solder these wires in place. I've given up on solderless disconnects for this particular transformer. The tabs are just small enough so as not to fit the disconnects. I've been troubled by these disconnects. It's the first time I've been using them, and I was concerned about those things loosening up, and I found that they in fact do. Now I'm mixing some epoxy glue, a relatively clear, sort of kind of more or less 5-minute epoxy glue. And I'm going to use that to insulate the tabs on the transformer secondaries, so that if you accidentally brush up against one, it will not kill you, at least in theory. Now, the next step here, I'm going to twist these wires together because I always have. It's supposed to reduce the electromagnetic interference. Now, these are like something in the order of 24 volts AC. They could generate enough interference to be annoying inside, and perhaps twisting these leads will reduce the annoyance. Twisting both of them, and I'm using heat shrink tubing to also keep these wires together. I don't want the rat's nest of wires all over the place. Now for the heat gun, also known as a hot air rework station. A heat gun is being used to heat up these heat shrink tubes, and I have a relatively nifty, neat arrangement at this point. I am now going to tin the tips of the wires coming from the secondaries. Those will then be soldered to the rectifier filter boards. I've been wondering about the necessity of this. I'm doing this as a carryover from some old practices. I'm not sure it's necessary. I need to know the drill size for these wires once they've been tinned. Having established some reasonably small drill size, I'm using a rotary tool at very slow rotation, and we'll now connect the wires as appropriate according to the labels that were previously put on. Crimp these wires in place, bend them, put some flux on. I like these flux pens when I'm working on boards. Crimp it, bend it in place, put some flux on, and solder it. I'm going to be thinking about these strips here. I notice that the strips have got holes, and I wonder if there's an issue with the connectivity here. I've got the secondary connected to the rectifier board. Now I'm stripping some wires that will be connected to the output of the rectifier filter boards, and they'll be used to ultimately connect to voltage regulators. Same deal here. Bend it so that it stays in place. Flux pen and solder. While I'm doing this, I'm checking to make sure that the strips are consistent and where they should be. Now for the common wire for the plus and minus 15 volt component of the internal supply. solder that in place. Kind of wondering whether I should just solder the whole thing from beginning to end down a particular strip to improve conductivity. I don't have to think about that. Let's wipe the flux off. Except that I just remembered I'm using isopropyl alcohol and acetone dissolves the labels I just studiously printed on the board. So let's see what's going to happen when I turn this board over. I need to trim these leads to make sure that they don't bounce up against the facing copper side. It's not too bad. I can still read them. And now I'm using epoxy glue to fashion strain relief for these wires. I used to use hot glue for this sort of thing and discovered that hot glue tends to peel off about 3 weeks after applied. I don't trust it. This fast-curing 5-minute epoxy, which cures in anywhere from an hour to 24 hours, is the stuff to use to fashion relatively permanent strain relief. Twisting the output of the rectifier filter boards. Now here it's just a matter of keeping these wires together. It's not much of an issue with electromagnetic interference once you've gone through the filter. There will be some ripple, but I don't think it's going to be significant enough to cause any interference. Anyhow, it can't hurt. I'm just going to twist these wires together. The idea is current flowing in one direction, creating an electromagnetic field, creates an opposing electromagnetic field. We have these wires connected, and now let's get some heat shrink tubing onto them as an additional way of stabilizing the wires, keeping the wires together. Shrink these heat shrink tubes. See if I can't do that without burning myself. These hot air guns are dangerous. In this video, I constructed a mounting platform for the rectifier filter boards. I soldered wire leads to the conventional transformer secondaries, insulated that transformer's connecting tabs, and connected the wires to the internal rectifier filter board's inputs. I then soldered wire leads to the board's outputs. In the next video, we will complete the connection and mounting of the rectifier filter board for the external supply, then test all the rectified outputs. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.